friends, welcome to science. So today we're gonna start learning about something very special and important. But there's two words that we need to know before we can start learning. The first word is transparent. Let's say that all together. Are you ready? Transparent. Transparent means an object that you can see through. You can see me through this glass. Good job. Transparent means something you can see through. Good work. The next word that we need to know is opaque. We're gonna say that one all together too. Are you ready? Opaque. Something that is opaque is something that you cannot see through. Watch this. You're not gonna be able to see my face when I put this book in front of it. See, this book is opaque because you cannot see through it. This glass is transparent. This book is opaque. Transparent, opaque. You may have heard the phrase that something can travel at the speed of light. But what does that really mean? First, we need to know that light travels in a straight line. When light, like from the sun, is moving through the air, it's gonna travel in a straight line. And light can go through a transparent material. But when it hits an opaque material, it's gonna bounce off. Then when we look at this glass here, do you see how it's kind of shiny? And my glasses have a little bit of a shine on them too from the light coming in? That's because when the light is traveling, it's going to go to the transparent material and it's going to bend. When the light hits a different type of material, like a transparent material, the light will bend. This is called light refraction. Over the course of the next couple weeks, we're going to be practicing our claim, evidence, and reasoning. That's something very special that we always do in science class. Remember, the claim is the answer to the question. The evidence is something you saw that helps you to know that your claim is the right answer. And the reasoning is, why does that evidence matter? Different objects make light move in different ways. Like when you see light through two different mediums, like through air and through glass, it can make the light move in different ways. Think about jumping up and down. When you're jumping up and down on the grass outside, it's easy and fun, right? But have you ever tried to jump up and down in a swimming pool? The water makes you move differently, and it's kind of hard to jump up and down when you're in the swimming pool. That's the same thing with light. When light is moving through the air, it's easy. But when light tries to move through different objects, it's a little bit different and the light will move differently. This is important for scientists to study because it helps them to see how light moves through different objects. Scientists were able then to invent glasses for people like me so that I can see better, telescopes to see objects that are really far away, and microscopes to see objects that are really small. Our question of the day is, drumroll please, can you bend a pencil without breaking it? Let's have some think time on that. Can you bend a pencil without breaking it? Ready, set, think. Let's take what we learned about light refraction to test this out. Now, I have three things here, the easiest things. I have got my cup from before. I've got a pencil and I've got some water. I'm gonna take this water and carefully pour it into the cup. Is the water translucent or opaque? It's translucent because you can see through it. Good work. Now what I'm gonna do, I'm gonna take this pencil and I'm gonna put it in the water. Now take a look at that. What do you notice? Let's see here. Do you see how it looks like the pencil is bent right there? Let's look at that. Is the pencil really bent? No, it's not really bent. Let's look at it again. Look at that. It looks like the pencil is bent, but we didn't break it. The light is able to travel in a straight line through the air, but when it tries to pass through the glass and the water, the light is going to bend, which makes the pencil look like it is bent. All different angles, look at that. So cool, look at that. We just bent a pencil without breaking it. Now we're gonna practice our CER. Remember, CER stands for claim, evidence, reasoning. Our question of the day was, can you bend a pencil without breaking it? Were we able to bend the pencil? With light refraction, it looked like the pencil was bent. So our claim is yes, we can bend a pencil without breaking it. Now let's think about our evidence. Our evidence is things that we saw, heard, or read that help us to know that the claim is right. We saw that the pencil looked bent. So our evidence is when we put the pencil in water, it looked like it was bent. Now the reasoning, that's gonna be the scientific explanation for why. And remember what we're learning about today? We're learning about light refraction. So our reasoning is because when light travels in a straight line and it hits a transparent object, the light bends. That's why the pencil looked like it was bent when we put it in the cup of water. Today we learned that light refraction can make a solid object like a pencil look like it's bent. We also learned that this is important for scientists and inventors to know because it helps them to make glasses, telescopes, and microscopes. How would you do this experiment differently? If you try it, make sure you leave a comment down below and let me know what you saw. Be good, stay healthy, and happy learning. Bye guys.